Hey everybody, this is Larry, this is me going Q2 of the weekly contest 331, minimum operations to make the integer 0. As you can see, I struggled a lot with it. I mean, I skipped ahead a little bit, but I came back to it and still had 4 errors. And to be honest, the 4 wrong answers came up after I figured out how to do it, quote unquote. Or made the observation. It took me a long time. I couldn't make the correct observation, right? I think the observation is, for me, and this was a very hard Q2, possibly the hardest Q2 I've seen, at least in a while. But I could be wrong, you know. I don't like I was with this farm, right? But yeah. But the idea is that let me give away the game a little bit. The idea is that the problem kind of changes after time, but instead of asking ourselves a variation of the problem is that, okay, so every time you make a move, you always have to subtract num2, right? So that means that as you make moves, you have to see if it's possible to do the move, right? So that means that, for example, for the first one, num1 is 3, num2 is -2. Then the first iteration, which, you know, with 0 moves, is 3, and then the second one's gonna be 5, and then 7, and then 9, and so forth, and 11, and dot, right? And of course, the rest of it is binary, so you have to think about if it's possible to make it with exactly that number of moves. So this is 0 moves, which is not possible, so we'll skip for now. So 5, we have to make with 1 move, right? So in binary, this is 101. We have to make with 1 move, which is not possible because you have two ones, right? So then the other one's 7. You have to make it with 2 moves. Did I mix this up? Yeah, and that's also not possible because, you know, then it's 9. What's 9? 9 is 8 and 1, right? So then now you have to make with 3 moves, and that is possible because you can do 100, 100, and 1, right? Of course, this is binary, so that's 4, 4, and 1. No, I think that's the only way to do it, to be honest, because you can kind of look at this conversation. But you can see that, so my initial guess, and it was wrong, is that the number of bit count has to be exactly the number of moves, but you can see that you can actually promote these, right? To, you know, 100, 100 to 1001, so that's good. So that's basically the idea. The idea is that, okay, as nums1 change, can you do it? There are a lot. The thing is that even after making this observation, and this observation for me took a long time, is that there's still a lot of edge cases. I got 4 wrong answers to show you. But yeah, but the first one is that, you know, nums2 could be negative, could be positive, so numbers can get smaller, right? For example, maybe you start at 9, and then 7, and then at a certain point you'll be -1. So if you try to do some bit count that way, you may get funky because -1 is just not possible to sum things up in binary to be -1. And then the other thing is that I had some. I mean, I think this one is a good illustration, but you have to have enough moves, right? For example, for example, maybe your number is let's say 7, right? So 7, 1, 1, 1. Can you do it in 6 moves, right? Or something like this? And the answer is, well, you have to figure it out, right? So 6 moves, you can do 1, 1, 1, 1, 1, 6 ones, and like a 10 or something like this. Maybe. I don't know if that's true, actually. Maybe 2 10s, right? Because then now, I think that's actually wrong. But in any case, you can see that, you know, let's say an easy example is if you have to create the number 1, and you could do 2 moves. Oops, caps lock. Well, you can't do it because your minimum for choosing I is 0, so that means that you have to choose at least 1 every time. So after 2 moves, your number will be at least 10 or 2 10 in binary, 2 in decimal, right? So those are the things that I had to check for and really discovered painfully, and also off by ones. So this is basically my code. I don't know that you have to go up to 1,000, but I assume that after 1,000, you just ran out of bit counts and stuff like this, right? Either it gets too big or too small. I don't know. Maybe I'm wrong on this one, to be honest. So definitely let me know if there's a case. But it was a guess. But you can probably prove some upper bound with respect to the number, because then at that point, this should already be true for a lot of it, right? So yeah. Here we, as we said, we subtract the number, and then now we see if the number is possible with exactly I moves, and that is of course if the bit count is less than I, because if it's more than I, then you just don't have enough moves, and that you have the number 1 itself is greater than or equal to I, so that if they're all ones, that's good enough. And apparently that's good enough, so that is the solution. This is a very hard for me solution, and of course this is technically exponential because this grows in the number of bits. Maybe not, I don't know, but maybe linear in the number of bits. Was a very hard problem for me. Let me know if you did it another way. Let me know if you did it, and you're curious about it. But I think the observation is the hardest part for me. I think I just kind of got, to be honest, I got a little bit too impatient after trying to figure out, and then once I figured out, I was like, oh yeah, obviously, like you do when you figure out problems. And then I just kind of didn't think about all the edge cases because I was underestimating it. Because basically I was like, the classic thing of you do the really hard thing, you did the hard part, and then you take the easy part for granted. I just didn't follow it through. So yeah. That's all I have for this one. Let me know what you think. Like I said, this is a very tricky one, so I'm curious about people's comments, and yeah, come to Discord and chat as well. And yeah, and you can watch me solve it live during the virtual contest. Now, watch this one a little bit, so I may eat it because I'm just like going a little bit fast. Alright, minimum operation, make an integer 0. Okay, choose an integer I and then subtract 2I plus num what from it. What does that even mean? Nice. So do you want to subtract 2I plus that? What does that mean? Does that mean anything? And nums I can be, or nums 2 can be any number. Wow, I don't know that I have an immediate idea about this one. Minimum number of operation. How do you even know it's not possible? Well, in one move. Can you do in one move? Can you do in two move? Can you do in three? What does that mean? It's basically num sub 2 times whatever, right? So you have to do it either way. So then now, so you just simulate it for, if you just simulate it for, how many operations can you even do? I don't know, maybe 100 should be good enough, right? Basically, you know you're making progress. No, that's not even true, is it? What the? And you could choose the same I more than once. That's a little bit confusing. even true? No, because then you could be negative and then go. This is ridiculous. Don't even make progress. So 3 is that. Wow. Maybe this is just not my contest way. Huh. I don't know that this is true. I think that this is maybe a red herring. Oh, like this is true, but maybe that's not the best way to do it. Let's see. All right, so you have 3. You have to add. You have to add 2 no matter what. So now you have 5. So then can you make progress? You make it 1, and then okay, that's not 0. So then you have to add 2. So then now you're back to 3. So maybe that's not the way to go because now you're looping. All right. Oh wait, no, that's fine. No, I mean no, it's. Then I know you go 1. Right? No, that's not good. No, that's probably not the way to go. It's not the bitwise thing. Wow. The negative one. What the hey? How can it be proven? Prove it to me. Huh. Can we breadth search? What happened to we breadth search? Wow, I have no idea how to do this, to be honest. I don't even think I can prove force in a good way. Well, I mean, I guess BFS prefers, but wow, I have no idea. This is Q2. So, alright, so now we start 3, we go to 5, and then we, in theory, we want to. That's not what they say to do. I guess that is what they say to do. You get to 1, and then now you go to 3, and then now you're minus 4, so now you have negative 1. Then you add 2 to get to 1, and then you're Gucci. But how would I know to get to negative? Oh. And why not like minus 8 so you go minus 3? Minus 3. You do nothing. You go to choose 0, so then you go to negative 1. And then negative 1 is the same as that one. But negative 1, you go to 1, and then that's good. I mean 5, and 5, you subtract 7 no matter what. Okay, I see why this is impossible, because you always go negative, and once you go negative there's no going back. But we still have to do minimum. It's not even a binary thing. I don't know this one. I'm gonna skip ahead. Alright. I mean, there were a couple of silly. Oh, I'm not done yet. I forgot. How am I doing now? Oh, jeez. Jeez Louise. I mean, I had that one the entire time. I just kind of made it tough. This one I still don't know. A lot of people got in it though. Wow, people did Q3 pretty quick. Oh, but I spent a long time on Q2. That's why Q3 is easy. Yeah. Well, I still got a wrong answer. Oh yeah. Man, this is a sloppy contest today. I still don't know how to do this one. Okay, I see. Okay, now I think I do. Is it 2 to the I? I see. I think I see it. Okay. So basically, I don't know if I can just do this for like 100 loops or something. Maybe 1,000. Doesn't really matter. And then basically num1 subtract num2 if is it like a bit count thing in Python? I feel like I've maybe int dot bit count it. Yeah. If num1 dot bit count is equal to I plus 1 maybe. Return I. Return -1 maybe. Something like that. Yeah, okay, maybe not. Hang on. I feel like it's something like this, but maybe I'm off by 1 or something. Because basically we go from 3 to 5 to 7, and 7 is 3, right? Huh. Why is this wrong? Why is it printing so much stuff? You should have returned it. Oh, because of the -1 on the first one for some reason. Okay, so 0, 3. Okay, it counts 2, 5, 7, 3, right? Okay, so I plus 1. 1 -1. Oh, what? Oh, I have to return I plus 2? That's really awkward, but okay, fine. Right answer at least? Okay, fine. This one is a pain. I don't know if this is right even. Oh yeah, oh, so this doesn't have to be 100. I mean, because you don't have enough bits anyway, so. Alright, let's give this a try. Oh, maybe I haven't considered this too much. Expected 3. Okay, so maybe I'm wrong on that one. Wait, let's see. Expected 3, I put -1. Okay, fine. Why? Tell me why. I thought I had it though, to be honest. Okay, so for 3, number is 68. Big count is 2. Why is it just returning 3? Okay, so so maybe that's not, it's not precise, but I think if it's fewer, maybe that's good enough. I don't know. Okay, so after 3 iteration, should be 68, right? What's 68? 68 is 64 plus 4. Oh, because you could do 64 plus, oh yeah, 64 plus 2 plus 2. How do I generalize that? Is it this? I didn't think there was this bit. Alright, for 5 and 7. Oh, I have to do if num1 is greater than or equal to 0, and this, maybe? I forgot about the negative numbers though, so. Still not good. Oh, it's the other way. Oops. That's why. I was really confused. I had to click on this button. 315. Should be 3. What the hell? So I is bigger than 2. Why is that not right? Oh, it's because I'm returning plus 1. Was it 3 again? So after one move, well, technically it's not 2 moves yet. That's why. Hope this is right. Yeah, I really have no idea how to do this, apparently. Oh, because it is exactly 0. I actually was thinking about this case. I mean, not this particularly, but this case where it is 0. But, so basically... so many cases. I'm gonna mess this farm. Mess this contest, really. Ah. So there's more cases. 85 after 2. After 2 is 83. Did I miss some? It's 1 and 0. That's why. So the numbers have to be, so it has to be bigger than 1. Is that true? Or am I just like randomly putting in numbers? So the bit count has to be, well, if it's greater, it has to be at least greater than 0. Is the current one. But oh, wait. Basically, this comes from the fact that you can combine 2 smaller ones into a bigger one. So it has to be this. This is so... I get the idea, but I think I've been trying to shortcut it through it. And that's why I keep getting wrong answers. Basically, after I moves, it has to be bigger than... But the bit count is nums 1 have to be bigger than I. Not the bit count. Because that is the number of... Oh no. Was that one of the inputs? No, okay, at least I'm not that bad today. Wow. This is the most long answer I have in a while. Expected 1. I guess it's maybe like a -1 thing. So after 1 move, yeah, maybe I was just a little bit sloppy on this one. Alright. Yeah, I mean, you know, only 5 wrong. Hey everybody, thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this contest, this problem, and all these things in between. I'll see you soon. Stay good, stay healthy, to good mental health. Goodbye. Boo boo.